Hey, all right, and this is take two, this time with audio working. Thank you for the warning there. So it's me, John Park, and this is JP's Pick of the Week, where you know it's live because weird stuff like that happens. So what I wanted to do, first of all, is say that if you're not watching this on the product page, head on over there and do that. This is, as you know, spoiler alert, this is the product right here, BNO055, the 9 DOF orientation sensor. It's product 4646. So if you go to adafruit.com/product/4646, in fact, I'm going to bring it up right now. There it is. Why do I say go watch it there? Well, yeah, first of all, it's just kind of snazzy that we've got the video playing inside the product page live. So that's a fun place to watch it. Obviously, we like that because it gives you a big add to cart button right there. But it allows us to try out some funky new stuff. So check this out. This is a special price on the product right now and only during this live stream. This is normally $19.95. It is 50% off right now. It's $9.98. That is crazy. So this is good right now, next 20 minutes or so as we do this show. Only limit is, I think, 10 in your cart. That's the max. We don't want anyone to go bonanza with this and start reselling them or anything like that. So, but if you have a big project that involves 9 degree of freedom IMU sensors with great fusion of that data, and I'll talk to you in a minute about what that means. This one's a hard one to beat. And right now it's $9.98. So go check it out there on the product page. So let's get back to the matter at hand. So this is going to be a Stemma QT board we're talking about. If you're not familiar, Stemma is our plug-and-play, easy-to-use board sensor add-on screen relay system that allows you to plug boards into other boards without any breadboarding necessary, without soldering, without even having to figure out which wire goes where. It's dead easy. You can only plug it in the right way. And you can plug in multiple boards into each other. In fact, I've got my wall of Stemma QT boards here. These can be plugged one into another, and then give you all those add-on peripherals for your microcontroller to talk to. So this is going to be a Stemma QT board we're talking about. And what I'll do is let's head on over and grab this from the cabinet of mysterious good fun and loveliness. All right, I'm back, and I've got it right here. Let me show you it. I'm going to show you a little glimpse of it. There's the board right there, and you can see I've actually got it plugged in already for some very specific and important reasons that we'll go over in a second. But there's the board. You can see I've got it plugged in over a Stemma QT into a microcontroller over here, and then we've got another Stemma QT output that we can plug into something else if we want to add more peripherals. So before I talk about this board, what I'd like to do is jump back in time to March 2015 and talk to Lamorfried, Mrs. Lady Ada herself, about the first version of this board. This is actually a revision that we're showing here today, but here's Lady Ada to talk about this board and why we like it.
So this is a really interesting sensor, and you might be saying like, wow, Lady Ada, you have like so many 9 DOF sensors. Why do you have another 9 DOF sensor? Like, aren't we already 9 DOF enough? Is there enough DOFs? So this 9 degree of freedom sensor is a very interesting one, and it's different than any other one that we've seen before. It's kind of one of a kind. This sensor has built-in sensor fusion. Not like a nuclear reactor. It actually it has a little microcontroller inside of it, and it can detect by taking all of the sensors, the magnetometer, the accelerometer, and the gyroscope, and it can take that data and it merges it together to turn it into orientation, like true, like X, Y, Z pitch, roll, yaw orientation that you don't have to do the math for. Because like chances are, like if you've ever had a 9 DOF or 10 DOF sensor and you're like, yeah, I have like all these degrees of freedom. Okay, I'm gonna like be able to tell where my thing is in space, and then you hit like Kalman filters and like AHRS like filters and code, and you're like, oh my god, this sucks. And you have to know a lot of math, and you're like, what's the difference between Euler and Quaternion? And like, this is like, it's not fun, and even like Arduinos struggle with it. And if you're doing something that has like a quadcopter or like robotics, and you're doing all this other stuff in the background, it's very hard to do that math. So this sensor, it's actually, what it is actually a little circuit board. Like, it's amazing. It's a teeny little circuit board that's epoxied on top, and it contains a 9-degree freedom sensor and an ARM Cortex M0. It's called the BNO055 from Bosch. And so this sensor, like, you can ask it, just give me like accelerometer, magnetometer, gyroscope, but the power is at 100 hertz or so. You can also just get it to give you true orientation, and like it just gives you like the vector, like you're done. Like you don't have to do any math, you don't do any calculation. It just gives it to you correct, like right out of the box, like instantly. So really, really easy.
How fast is this giving you data?
You can do 100 hertz on the Quaternion or Euler or gravitational vectors. It's actually in the product page. There's some calculations, like I know temperature, you can only get 1 hertz, but I think it's about 100 hertz. And it's very, very stable. Like when I first got it working, I was like, is it crashed? I'm like, oh my god, and it's actually just not drifting, because I'm used to having the gyros drift a lot.
There we go. Yes, we're back, and thank you to C. Grover for that alert. I had a crash. I had a software crash, so a couple things had to come back up. So sorry for that, but we're back. And so I want to thank Lady Ada for talking about that board. And you can see that was a board that was originally a Breakout that you would put on a breadboard. Now what we have is this lovely Stemma QT version, so it's easy plug and play. And you can see from the one that I have here, let me jump over to this view. So what are we talking about? With this type of sensor, what you care about. So there's a few things going on. First of all, what's 9 degrees of freedom? That means that this is giving us essentially rotational positioning data from 3 axes of an accelerometer, from a magnetometer, and from a gyroscope. And all of that data can be massaged and fused to give us the thing we really care about, which is a heading, pitch, and roll. And sometimes these are called yaw, pitch, and roll. Sometimes these are called just X, Y, and Z, depending on what application you're using them for. But those are kind of what we care about, is those vectors. And there's a lot of data that needs to be computed, which is way too much for most microcontrollers to deal with, frankly, and still do other things. So that's the beauty of this board. It just is giving me the thing I want, which is where is this thing pointed in space. And the reason that I built it onto this sort of little motion platform, gimbal rig that I made out of some Lego Technics parts, is that it allows me to demonstrate that heading, pitch, and roll on the board. And what I'd like to do is show you how that can actually be used in practice. So like we said, these can be used for navigation, for robotics, for personal fitness, for drones, for toys, for laptops, but I'm going to use it here as a 3D controller. So what I have is a demo that was originally, okay, I'm gonna have to fix a piece of this software that crashed here real quick. There we go. Let's see if this thing survived it. All right. So here we have a application that was originally written by K-Town, and then Melissa made this updated version. It was originally in processing. This is a version that Melissa made for us that uses web serial. So I'm streaming serial data into the Chrome browser. And if I open up my Chrome browser here, what you'll see is that as I rotate the BNO055 in its heading direction, so this is actually true north. That's why I have it kind of angled here in my camera. For where I am right now, that's north, and so that's considered 0 in the orientation of this model. What I have here is this cool 3D model that Pedro made for our, it's the Queen piece, the Lady Ada Queen piece from the chess set. There's a 3D printable chessboard you can find in the Learn Guide section. And so I've updated our viewer. Instead of the bunny, we have this Queen Lady Ada here. And the application is just feeding that heading, which is this. It's feeding that pitch, which is this. And it's feeding roll into the model. And like Lady Ada said, look how stable that is. If you've ever done any type of sort of IMU stuff for 3D model use, generally it jiggles a lot. It floats and drifts and jiggles. This thing is lock solid. You can see that the output that I'm spitting out there will update, and it streams a little bit. I think that's just lag from me streaming it to the software and it scrolling it at a rate that we can see it. But if you look at what the model's doing, it locks in really nicely into these rotation axes. So we mentioned that there are both Euler calculations, which is essentially x, y, and z, as well as quaternions, which is w, x, y, z, and it gives you a more stable, less prone to gimbal locking when you essentially align two rotation axes on a plane with each other. So we can do both modes. This is in Euler mode right now, and you can switch this over. And we have a guide that shows you how to set this up. This is running an Arduino sketch, and the funny thing about the Arduino sketch is there's really one line that matters, which is just, hey, ask this BNO055 where it's pointing, and it gives all the data that we need, which we can then provide to the application on the other end. So you can see here, we can of course take this off. I've just got this stuck to the Legos here. I can take this off and move this around freely. It doesn't have to be on that rig. And you'll see we can go fully upside down. We can rotate this all the way around. A little easier if it's not stuck to my jig here, but I wanted to do that to make life easy. Also, one nice thing about this is the way that these are initially calibrated. You'll see on the side there it says there's a calibration for gyro, accelerometer, and magnetometer. The accelerometer wants to be essentially the Bosch software living on the chip just looks for you to move it on one axis in 45-degree increments in a full completion of 360. So we simply go 45, 45, 45, 45, 45, 45, 45, 45, and at the end of that it says calibrated. Sometimes you might have to try it twice if you're not stable enough in each position, or you don't, if you're not patient enough. But I found it actually works really well just to follow that guideline. And in our guide for this, we have info. In fact, speaking of the guide, let me pop back over to that page, and I'm actually gonna make a new tab in this browser and go there. So let's see, product 4646. I said 4646. Head there. Again, you'll see this is 50% off right now, so go get one. That's bonkers pricing. I think this was $35 when it originally came out in the first form in 2015, and then it got down in the Stemma version to $19.95. And now we have the discount today. So if you head down to the Learn Guide from here, this will show you how to set up this exact demo I'm using. We have pictures of both versions of the board here. And if you go down to the Downloads section, you can click on the Bosch datasheet, which is interesting. You can also look at both the Python and Arduino examples. And if you look on I believe it's here in the device calibration section of the Arduino code page, there's a nice video to watch from Bosch talking about how the calibration works. But the nice thing is it's happening all on the device itself, and it's sort of magical. So here it is. I've still got it working. That's great. This is experimental feature in Chrome, so sometimes it doesn't love to stream lots of data. I've got it running at about 200 milliseconds per update. You can go faster. You can go up to 100, but I think that confuses Chrome sometimes. But pretty good. And a use that you could find for this is streaming this data into something like Maya or Blender to use as a motion capture camera control rig or an object orientation rig. That's sort of uses for this sort of thing that are near and dear to my heart. But I'm sure you'll find lots of interesting uses for it. And that is why this is my product pick of the week. So If anyone has questions about it, hop over to the Discord chat. I'll go check that out. I think that's all I wanted to show. So what I'll do now is let me pluck this delightful little board off of here, and I'm going to add this to my little Stemma QT pegboard there. Not so little, I guess. And we will wrap it up. It's got these little 3D printed hang tags. We'll set that there. And that one is complete. So thank you for coming by today for JP's Product Pick of the Week. Head on over for the next few minutes while that crazy sale is still on and get yourself 1 or 2 or 8 or 10, maximum of 10. And let us know what you use it for. Post about it online. We want to see how you're using this thing. And one of the beauties of it is you can use it with some tiny microcontrollers because it does all the hard work. So plug it into a Trinket or something, or maybe the new Pi QT. Or QT Pie, I should say. So that's about it. I'm John Park. This has been JP's Product Pick of the Week, and I will see you next time.